Hey guys, guess what? It's time to do some more science today. You ready? I am. So today we're going to be learning about fossils. Yeah. Hopefully you've already learned a little bit about them. And you know what kind of rocks they are found in. Do you know? I can't hear you. What kind of rocks? Sedimentary, that's right. So fossils are found in sedimentary rocks, and fossils are made in those sedimentary rocks in different ways too. And there's a few other ways they're made in not sedimentary rocks, and we're going to learn about those. So the first thing we need to do is look at all the different types of fossils, or at least most of them. So let's see. There's the cast fossil, the mold fossil, the imprint fossil, and the amber fossil. Now the amber one is pretty obvious. It's sap, it's tree sap. The bug gets stuck, the sap hardens, turns into a stone called amber, and the bug is fossilized inside the stone forever and ever and ever. And the cast fossil is pretty easy too, because you ever had a cast on your arm, or your leg, or your neck? It's the shape of whatever body part it's on. So a cast fossil is actually like the 3D version of that animal or plant or shell, whatever it is. And so it looks like the 3D version. It's kind of like a pop-up. Well, the mold is the leftover spot where that thing died and decayed and decomposed away. So it's the leftover spot. As where imprint is different, is where something has left a print and then went on. Like a dinosaur walks through and then you find the tracks. Or a bear's walking through the woods and then you find the tracks. Tracks are imprints. Molds are where the thing actually died. And died. And decomposed. And decomposed some more. And decomposed some more. And decomposed some more. And it left the shape of it there. You're going to see what I mean in a video in just a second. Let's check out that video and see what we can find out. So listen carefully.
Fossils are the stone remains of animals or plants that were once alive.
She's really smart.
Fossils can be the bones of a dead dinosaur or his big footprints in the sand.
Imprints.
Usually, only the skeletons of animals are left after millions of years.
This is a different one.
Sometimes a whole animal, like a woolly mammoth, gets trapped in the ice. The ice stays frozen for thousands of years, and paleontologists are lucky to find a whole creature that has barely changed over time. Or an insect gets stuck in tree sap. The sap hardens into a hard, clear material called amber.
Sounds familiar.
These creatures look just the way they did when they first wandered into the sap millions of years ago.
Really?
Let's look at the way dinosaur bone fossils are made. Most dinosaur fossils are formed by mold and cast. Imagine a stegosaurus drowns in a river and its body sinks to the bottom of the riverbed. The flesh of the animal rots away or is eaten by smaller creatures. Eventually only the bones are left. Mud and sand, called sediment, cover the skeleton over many years. More layers of sediment fall on the skeleton. Over time, the floor of the river sinks from the weight of the sediment. The lower layers of soft mud and sand are pressed into hard rock. Now the skeleton is completely surrounded by compressed stone. The bone is slowly washed away by little trickles of water. This water is called groundwater. The bones leave an open space in the exact shape of the dinosaur skeleton. This open space is called a natural mold. Now the groundwater brings tiny pieces of rock into those empty spaces. After millions of years, these tiny rock pieces fill the mold. The rock is pressed further and further underground. Over time, the entire skeleton mold becomes solid rock. Many years later, the rock surrounding the skeleton rises to the Earth's surface. This can happen during an earthquake or as mountains rise naturally. The top layers of rock are worn away by wind and rain. Slowly, wind and rain show the fossils to the outside world. Not all fossils rise to the surface. Many times they remain under layers and layers of rock, and paleontologists have to dig a long time to find them.
So, pretty cool, huh? Fossils are everywhere. They can be found in all kinds of different places. And they're made in a pretty nifty way too. So the sediment settles and get pressed and the fossils get stuck in between. And as you saw, the mold is created where the bones were laying. So there's a mold there. And then the cast is made from the sediment filling up that mold and recreating the bone. So it looks like a 3D version of it. So you have cast and mold. We won't see imprint very often, and you won't see amber very often, but you do need to know cast, mold, and amber. So let's see. Thinking back to the video we just saw, let's see which one this is. Dead organisms such as insects become trapped and preserved in hardened tree sap. What is that? Cast and mold, freezing, or amber preservation? Did you say amber? Why, yes, you were correct. All right, what about this one? The low temperature of frozen soil and ice preserves the dead organisms from decaying. What's that? Huh? Freezing. They get stuck. It's like Ice Age. Then what about this one? Minerals dissolved in the groundwater replace the organic parts of the organism. Gradually, the remains change into rock. Oh yes, that's cast and mold, so it gradually changes into the 3D version. You're right. So how do cast and molds form? Well, you've learned it twice now. Once from me, once from the video, and then we just talked about it again. So let's see if you can do it. What's the first thing that has to happen? That's right. The animal has to die, unfortunately. Well then, the next thing has to happen. Yep, the shell decays and a cavity or mold is left behind where it was before. Then after that, oh wait, I think we messed up. Do you see something wrong? I think the mud has to cover the shell. And then the shell decays into a cavity, and then the mud hardens into sedimentary rock, and the minerals, hang on, fill the empty space and take the form of the shell, and then the minerals harden, forming a fossil. So let's see what it happens. Let's see if we can do it. The animal dies, the mud covers it, it decays, and there's a cavity or the mold left behind. And a cavity is like a hole where something was at one point. But in this case, it looks just like it. And then the mud hardens into a rock. And then the minerals from the water fill in that empty space and take the form of that shell. And then that hardens into a fossil. Crazy, huh? Takes a long time. So what can we learn by studying fossils? Well, they tell us a lot of important information about the animals and plants that lived in the past. We wouldn't know dinosaurs existed if we didn't have fossils. So think about that. Shout some ideas to me. What can they teach us? You said dinosaurs? Yeah? Did you say about plants from a long time ago? What else? They can teach us about the Ice Age animals. Yeah, that's right. Anything else? Maybe what kinds of animals or of animals lived in that area a long time ago. Those are some really good ideas. Uh-oh. Those are some awesome ideas. Great ideas, kids. Well, let's talk about it. Fossils can tell us where things used to live. They can tell us the size of animals that used to live there. They can tell us whether the animal was a meat eater or a vegetarian, So in other words, an herbivore or a carnivore or an omnivore, based on the teeth that are in the fossils. We can tell if it was a bipedal animal, in other words, it had 2 legs, because bi means 2, based on the fossil. We can tell what the favorite food is, and we can tell what years it lived, because we can age the fossils and see. Can we tell about the skin color? Nope, because the skin color will be gone. Will it tell us why they're extinct? Nope, we have to make our guess. Will it tell us how many? Nope. You'd have to find all the fossils. Plant eater? Yep, it'll tell us. And it'll also tell us if it was a quadruped. What does quadra mean? 4. So if it has ped means foot, so 4-footed animal. We can tell all of these things based on fossils. And we can also tell what kinds of animals live there. So for instance, if I found a shark fossil in the mountains of South Carolina, that must mean the mountains of South Carolina used to be the ocean. No way. Wow. That's a nugget to think on. Maybe your teacher can give you some more ideas for things like that. See what you can learn from fossils today.
You and me, baby, we're stuck like glue. Whoa, whoa, whoa.